Hi, so in this video we are going to learn how one trigonometric ratio gets changed into another trigonometric ratio depending upon the angle. You must have seen that you convert sine 90 minus theta into cos theta or cos 90 minus theta into sine theta, and sometimes the values also become negative. So why is it so and how it happens, all that I'm going to cover in this video. So I explained you the values of trigonometric ratios using unit circle. That means by using the circle whose radius is of unit length. So suppose if I draw an angle theta over here, then the coordinate of this point are represented by cos theta, sine theta. The x coordinate of this point is cos theta and the y coordinate is sine theta. And that is because if I draw a perpendicular from this point to the x-axis, then this becomes a right angle triangle where this is 90 degrees and this, if I assume as the origin, that is 0, 0, and if the coordinates of this point are x and y, then length from here till here will be x and this length will be equal to y, and sine theta will be equal to y divided by the radius of the circle, which is 1 in this case. So sine theta will be equal to y, and cos theta, which is base divided by hypotenuse, that is x divided by 1, then the value of x coordinate of this point will be cos theta, and that is why they are represented like this. So this much we have learnt earlier, and now we are going to change this angle to 90 minus theta, 90 plus theta, and then we'll see how the values of cos and sine change from one value to another. And if we can fix the behavior of sine and cos, we can very well fix the behavior of other trigonometric ratios, that is tan, cosec, cot, and sec. So let's do that. So here let us assume that this is 0, 0 and this is angle theta. And if I convert this into a triangle, then it will look something like this, where this angle is theta. So the coordinates of this point are cos theta and sine theta, right? This we have discussed. And now let us talk about cos 90 minus theta and sine 90 minus theta, right? Where this angle is theta, then this much angle will become 90 minus theta. So here if you see properly, this triangle, the triangle in purple and the triangle in orange, they are congruent triangles. That means this length is actually equal to this length and this length is equal to this length. That means the coordinates of this point, the value of x coordinate of this point will actually be equal to the value of y coordinates of this point, that is sine theta, and the value of y coordinates of this point will actually be equal to the value of x coordinate of this point, that is cos theta. That means cos 90 minus theta, which is the value of x coordinate of this point, will be equal to sine theta, and sine 90 minus theta, that is the value of y coordinate of this point, will actually be equal to cos theta, right? Similarly, if I talk about 90 plus theta, then that theta will be somewhere over here, and again this triangle will be congruent to this triangle and this triangle also, where this much is equal to this much and this is common. Then the coordinates of this point will be cos 90 plus theta and sine 90 plus theta, and here we have positive x, and in this direction this is negative x. That means the coordinates of this point will actually be equal to this much length is on the x-axis, which is equal to this length on the y-axis, which is equal to sine theta. That means the coordinates of this point will be equal to minus sine theta, because this is on the negative x-axis, and cos theta, because this is positive axis, right? So that is why cos 90 plus theta is equal to minus sine theta, because it represents the x-axis, and from this point onwards on the left hand side the x-axis is negative, so this will be minus sine theta, and sine 90 plus theta, that is the y coordinate of this point, is equal to cos theta. And now if I talk about 180 minus theta, then this will be a triangle something like this, where this is angle theta, and this triangle will also be congruent to this triangle, where this much length will be equal to this length and this length will be equal to this length, right? So the coordinates of this point will be equal to length on the x-axis, which is same as here, that is cos theta. So this will be equal to minus cos theta, and this much length will be equal to this length, that means the y coordinate will be equal to sin theta, and this is on the positive y-axis, so this will be positive sin theta. So when we talk about cos 180 minus theta and sin 180 minus theta, this is actually equal to minus cos theta and sin theta, right? And similarly, if I talk